Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy.
Hello Arun. So today I'm going to explain you how to measure the elastic modulus of a given lattice structure. Okay. So after conducting the compression test, we have got this particular results where we have the time, extensions and load and compressive stress. I think yeah, compressive stress and then compressive strain. Again, compressive extension and compressive strain. Okay. So here we need the raw data that is extension and load. So let's copy these two data. Okay, so press the shift, then select this. Now just give the right click and copy it. Okay, so let's create the new worksheet. Here we have created. So now you can copy paste as a number values. Okay, so let's copy paste them. Okay, I think yeah, you can remove this data because let's delete this. Yeah, let's delete this row as well. Okay, so here we have got this particular data where we have the extension. We can also call it as a deformation of the given particular lattice structure and the amount of load it bears during the compression test. Okay, so here we have the values up to 1984. Okay, up to is 16 mm height, say like a 16 mm point of you can say that 16.5 mm deformation. Okay, so now here the next step is we need to convert the extension load versus displacement into stress versus strain. So let's create the two new columns strain and its unit as mm per mm. Why? Because our extension is in mm, so that's why we can also considering that as mm per mm. Now you can also write like a stress. Okay, and the unit of stress is like MPa. Okay, now as we know that the strain is a deformation over the height of the given sample. Here our sample is the lattice structure. So now the height of the initial height of the lattice structure, as we know that let's create the formula by pressing the equal, and now let's select the deformation and deformation per over the initial height. What is the initial height of our sample? So that is I think 21.6 mm. So let's go with that 21.6 mm. Okay, so this is our strain formula, deformation over the initial height of the given lattice. So let's press enter. Now you can double click here. So it can consider the throughout the column of given. You can also check once. So by pressing the control shift and down arrow. So here our strain is up to 0.76. Okay, so we have compressed our lattice up to 0.76, like 76% of the strain. Okay, now what is the formula for stress? That is you can press the equal and let's select the load for the for initial cross section area. What is our cross section area of the sample? 20 mm length and 20 mm width. Okay, so 20 into 20. So this is our stress formula. We have entered the entered. Now again you can double click here. So like that we have measured the stress as well. So our stress is went up to 23 megapascal. I think it is in densification region. So let's plot these two graphs. So before plotting, what I can suggest you as here initially we can separate these two columns now by pressing the you just go here and then press right click there and insert the new column. So we have separated, but still you can maintain the formula of the given relation. Okay, so here, if you observe the initial values of given either extension or stress, strain or stress, here there are some negative values. So it is due to the experimental conditions. So what we can do, just you can observe up to where we have those values. So I think here up to here. So here why we are removing this, even I can tell you why, what is the effect of this. So let's plot these two. Okay. So here, so this is our stress strain curve. Even you can see clearly. Okay, I press the control cut paste and let's paste it here. So here, if you see this, initially, even what I can say, just right click here, like you can select this series and select the edit. Here, the you can type the values up to 100, and as we have the maximum values like 100, yeah. Here you can see there is a some like non-linearity in the given data. So we are trying to remove that particular data. Okay, and as well as we are trying to connect exactly, we are trying to start our values from the zeros with a linear. So for that we need to evaluate the elastic modulus. So so in this lesson we are trying for measuring the elastic modulus. That's why what I am suggesting you to remove this initial data, and later on I will tell you how to exactly measure the elastic modulus. Okay, let's delete this particular plot. Now we can remove this. No, just you can come get it, just press Ctrl Z. So let's see what is going to happen. Till, because we have the negative values up to here, from here to here we have the negative values. So let's remove this particular data. Okay, I think you can remove these particular strain values, and okay, and make it 0. And here you can remove this particular non-values, shift to cell up. Now you can see mostly we have removed our particular values. So still we like there is a nonlinearity. So for that I will we need to measure the elastic modulus. I will explain you how to do that. So let's delete this, and here you can make it as a 0, no problem. So you can go down. Here there is some deviation in the value, so let's remove that value by pressing the delete button. Now it is equal, it has equal value. So let's go up. Now we have there is no any negative values. Now we started our values from the zeros. Okay, yeah, let's go and measure the elastic modulus. So for that you simply press the shift and press this here, now you can measure up to here. And let's go to the insert tab and go to the chart tab, and select this particular one. And here you can see, you can select the scattered one. Okay, what you can see there is some deviation, and you can go to the select data, just press the right click, go to select data and select this series one, and go to the edit tab. Here you can we are up to, we have 21 values, so let's give the 100 values even here also. Yeah, so here from 0 we have the nonlinearity and nonlinearity, and then we have the linear region, isn't it? So we can measure the elastic modulus from 2 megapascals to, like, from 0.5 to 2 megapascal. So I think that is a perfect linear region. So like that, you need to always check where is the linear region is coming. So it is most important. Okay, so we can select the data now. To measure the elastic modulus, we are going to select the data from 0.5 megapascal to 2 megapascal. So keep in mind. Okay, so let's check where is the 0.5 stress. We are now focusing on the stress values. Okay, so let's, here we have the 0.5. So let's select that particular strain values, and 0.5 to 2 now. Go down here. Here we have the 2 megapascal stress. So let's highlight that particular one. Okay, we have highlighted. Now you can plot that also. Either you can plot new or you can edit the data, but we can plot it simply. Yeah. Now you can say that it is perfectly linear, although there is some two data which are not linear, but still it is linear condition only. So we can confirm that from R square value. So now what you can do, simply right click, and here you can observe there is a add trend lines. Just simply press that. Okay, and here trend line we are considering the linear one, not exponential or logarithmic or polynomial. So we are only considering the linear one. And here there are two options. One is a display equation on chart. So let's check that. So here we have the equation, and now you can also check the R square value. Yeah, here you can confirm this. R square value is almost equals to 1.999. So it is a perfect linear. You can say that. Yeah, here as we here y is considered as a stress, y axis vertical axis, and this x is considered as a strain. So as we know, there is a relation between the linear relation between stress and strain, that is the proportionality is elastic modulus. So this 80.924 is our elastic modulus values. So let's copy that. Just press the Ctrl X and copy this particular plot here. I'm sorry. Just cut this plot, and here you can paste it. Here you can paste it. Okay, now you can delete this particular plot. Yeah, now you can write it here like elastic modulus, elastic modulus, MPA, no? MPA. So what is our value? So you can either say Here the value is 80.924. Okay, so this is our elastic modulus value. Now we want to start our values from the zero with a perfectly linear value, linear modulus. For that, what I can say, so let's copy this particular strain values and paste it here as a values 1 to 3. Okay, and now simply copy this particular stress value and just paste it here. Now, as we know that there is a relation between the stress and strain in terms of elastic modulus, that is sigma is equals to epsilon, like elastic modulus into strain. So that formula we are going to use here. So let's press the equal and select this particular value, okay, Q3, and press the, we want a constant value. Either you can type the value or press the F4, so it will become into the constant value like $q. So it makes, after pressing F4, so it automatically converts as constant value. Now you can enter this now elastic modulus into our particular strain values, isn't it? So here we have the respective strain value is this. So let's press enter. So now our task is, we have measured our elastic modulus from zero point 0.5 na, zero point 0.5 stress. So you can get that particular stress value up to 0.5. Okay, yeah, here you can say that 0.515 now. So we can copy here up to this. Okay, so this is perfect. Now you just simply copy this particular data from here starting onwards, to just press the control shift down arrow and copy this particular data, and you can go up as well. Now here you can press and go up, control shift up. Now here you can copy the data values. Now what you can see, there is a continuity now. So what you can do, so let's remove this particular cell. Okay, delete particular cell and shifts to cell up. Yeah, now it is connected perfectly linear. So now what you can do, go down. So we need to remove some of the strain values, so let's remove that. Okay, so now you can go up. Yeah, let's plot this and go to insert, go to chart tab and plot it. So see here, now it start exactly from the zero by maintaining the linear relation, and we have the perfect like stress strain graph. Okay, just place it here. Yeah, now even you can see that linear values by just select the, just press here, select data and select this series and select this edit option and press 100. See, now it is perfectly linear. Okay, so this is how you need to like make, you need to start our curve from zero by measuring the respective elastic modulus and by removing the respective negative values. So I hope you understood till now. So I will explain you how to measure the elastic yield stress of particular lattice structure by using this stress strain values. So I will explain you that in the next lecture. So I hope you understood till now. So it is very easy. So from starting onwards, what exactly we did, we have the extensional load and then we converted into strain and stress, and we have removed the respective negative values. And next, in the next step, we initially measured the elastic modulus values, linear values, and like here we have highlighted from zero point 0.5 to 2 megapascal. And for this particular linear region, we evaluated the respective elastic modulus value, that as 80.924. By considering this, we created the new stress strain values. Here we use this relation, okay, and we dragged up to zero point 0.5, and then we just copied this and here copied this to here, and then next we plotted this particular graph. So I hope you understood. So this is how you can measure the elastic modulus values. Okay. So so with this I am closing. I will explain you how to measure the elastic modulus yield stress in the next lecture. So stay tuned.